Hi everybody, this is Mrs. Peachy from your WCA Earth Science class. Today I'm going to be giving you a demonstration on the lab portfolio that you have for Unit 3, Modeling Thermal Convection. Just kind of going to go through what you need to do for this portfolio. I do want to remind you that all of your portfolios, you will see video tutorials. This is what I'm making right now on my website, along with a place to download the Microsoft Word version of the lab. So that's right here. And that's what I have up on the screen. So you guys can actually open up this Microsoft Word version and you can type all your answers in here. So let's go to the lab setup, okay? So here's our lab setup. What I have here is a plastic bin. You can use just a dishwasher bin, like a plastic. It doesn't have to be see-through like this. You could use a small shoebox tote. Those work really, really well. This just happens to be an old ice bucket that I had at my house. And what I'm filling this with is really, really cold water. So that's very cold water. I'm actually even adding some ice to this water to make sure that it's really super cold, because the bigger the difference in temperature you can get from what's in here versus what you have in the other container, the better. The other thing to notice is that there are 4 cups that you're just going to use as a base to lift up your ice container. And you'll need a 5th cup. And the 5th cup should be identical to those 4, because it's going to eventually just be able to slide right underneath here. Okay, so that's what you're going to use that 5th cup for. You need some hot water. I actually have some hot water right here. I put in a glass jelly jar. It does not slide under there. That's why it's going to be poured into this cup here shortly. You need some red and blue food coloring. It also says you could use some cardboard squares. That's really just to set these on so they don't slide. Mine are doing pretty good on their own. Your food coloring, it comes in little squirt bottles like this, right? Which is totally fine. These are dropper bottles all by themselves. You can use them. I'm going to use pipettes. Plastic pipettes, just because it's easier to demonstrate that, okay? So I'm going to toggle back and forth between what I'm doing here and what's on the screen, okay? Or the lab report. You're also going to need, it says melting chocolate or wax. For the second part of this, I actually have a wax burner that I use scented wax in to make my house smell nice. And so I have that plugged in, and I'm going to be using the wax from there as my melted wax for the second part. Okay, so at least 4 inches of water in here, right? Then it says draw some of the red food coloring up into the pipette and insert the pipette into the center of the cold water bin to deposit the dye above the bottom of the bin. Expel the food coloring slowly so it stays mostly in a dense circular area. So we're going to go ahead and try that. Put a little bit of red food coloring right in the center. And I'm just going to put some in my pipette here first. See me, I'm actually filling up my pipette. And I have not tried this yet, so this is going to be an interesting thing for me to try. Okay, so I'm going to put it in the center and just slowly drop it in. I want it to stay kind of in a circular area at the bottom. Obviously, I have a cloud of it at the top too, because my pipette was a little bit dirty, but that's okay. Then it wants you to do, going back to the sheet, do the blue dye about 2 inches to the left and to the right of the red dye. So I'm going to go a little bit to the left and to the right of the red dye and do a little blue here and a little bit of blue right there. So I've got 3 dots. Getting a little bit of condensation on here, so it's kind of harder to see right here. I got a little condensation. Let me wipe that off. All right. All right, you can see better. And then I'm going to fill my other cup with my hot water. Hotter the better. Just fill it right to the top. And I'm going to slide this under my red area. Just underneath the red dye. Let's see if I can make sure it's right under the red dye. Hang on. Okay. And you're going to kind of watch this. It'll take a little bit of time. Let me check with the lights off and see if that actually makes it better. There. Maybe a little easier to see with lights off. We're going to kind of watch this here. Just checking back in the directions real quick here. It says, observe how the dyes move within the bin as thermal energy travels through the system. It may take a few minutes to see the results. So we're watching down here. That's what you want to see. That red dye on the top there that I kind of messed up on, don't pay attention to that. Pay attention to what's going on right here. Again, you guys might have a better view of this on your screen, or when you do it in your own kitchen. I'm just going to pause this for a minute, let the changes kind of occur so that we're not just sitting and watching live. So hang on. Okay, so you can kind of start to see some of those changes here. Hopefully you can notice that we've got a few rising currents happening here above the hot water. It's important to kind of get some perspective here too, because that's where our hot water is, right? So that you get the rising currents above the hot water. But then notice how they're kind of coming back down here and sinking when the water's colder. Okay, really good ones now. You see that, ladies and gentlemen? Those really beautiful rising currents here. Those are your convection currents, right? You can see the motion. Oh, it's really nice. See, one of the things that's really important is making sure that this cup on the bottom is as tight to the container as possible. What I had to do is, do you notice how I have little feet at the bottom of my container? That meant there was a little gap here, so I actually put a wedge of sticky notes underneath of this cup just to make sure that it was flat and really resting right up against my plastic container, and making sure that hot water is all the way to the top. But they're getting some really beautiful action here. Look at that. You don't see that happening anywhere else, right? Just above the hot water. Now, I would highly recommend doing this on your own, but if you are lacking in materials and you want to use these observations from my demonstration as your data, you can do that. Oh wow, now it's working really nicely, ladies and gentlemen. Beautiful. Beautiful convection currents. Okay, I'm going to switch back here real quick. We are going to do the same thing, but this time we're going to use the wax. We're going to add the wax to this container. So I got to go ahead and clean these containers up, get them all refilled, and we'll have to start from the beginning, and we'll use the wax also. All right, ladies and gentlemen. So now we're continuing on where we were before. Now I put wax at the top of the screen. I put wax on the surface, and now I've got those convection currents. Look at how beautiful those are. You see them moving? Heating up, rising, cooling, and sinking back down. Let's see if we can kind of drag our continent over to the middle. I'm giving a little bit of my own motion, but I want you to see how And notice how it's kind of now getting pushed over a little bit by those convection currents. Fortunately, once it hits the side, it tends to like to stick to the side of the... There we go. Those wax globs might be just a little bit large. You might see them better with something a little lighter. Now what I used for the wax is I just used my wax burner. One of these wax burners. Some of you guys may have these at home, right? You put scented wax in them. Oh, now we see the motion. See some of those guys floating around up on top? I see some motion over here. Think of those as being the continents moving. Slowly, slowly being pulled along by the convection currents in the mantle. Beautiful plume. I'm actually seeing not as much movement in the wax as I would like. I know what it's supposed to be doing, dragging it along, but I'm not seeing that like I want to see it. And my guess is that my wax just might be a little heavy. So perhaps instead of making big islands of wax, I would make little dots of wax. Pieces that are a little smaller. Because they do tend to kind of be a bit heavy to move with those currents. But the idea is that they're supposed to be moving around, being pulled by the convection currents. And once we get some of those big guys out of there, the little guys will have a better chance of moving. The other thing I would say is maybe if your tank was a little shallower, you'd get a bit more drag at the top. But either way, that is a really pretty plume in the middle, convection plume. And just kind of pull apart some of these little guys. I'm going to actually disturb the surface and remove a few of these larger chunks out of here. And just leave some of the tiny ones in place. And just see if maybe we can get a little bit more motion. Okay. Another thing you could use on top if you don't have wax is just something lightweight like pepper or feathers or not feathers, pepper or glitter or something that would float and be very light. All right. I've also seen, ladies and gentlemen, you could use little drops of oil in place of the wax. Just little drops of vegetable oil or olive oil or something. That also might help. It would work more like a lava lamp at that point. I think now we're seeing a little bit motion here. Those big chunks were just too big. Now they're moving really nicely. Plates in motion. Plate tectonics. Sweet. All right, so now that is part 2. And you guys now have to do the analyze questions. Describe the motion of the red and blue dyes in the bin. Draw a simple labeled diagram to show the movement of matter and energy. You don't really have, since this is something you're doing on the computer, familiarize yourself with the draw tools up here. And you insert shapes. You can select this little squiggle shape here. It says scribble. And that allows you to draw. Now, you might not be a really pretty drawing, but you can draw what you need to draw, right? So familiarize yourself with that. The other thing that you can do, ladies and gentlemen, if you want to do your drawing on regular paper and just take a picture of it and attach it as a picture file, like a JPEG or something like that, that's totally fine. Some people may prefer to do that than to do. Make sure it's not just a drawing. It should be in color, red and blue, right? Arrows showing direction, but also provide a written explanation to explain what's happening in your drawing, and that goes below. Talk about density. How does density impact convection? Okay, so one thing we do know is that cold water is more dense than warm water. Things that are more dense will sink, and things that are less dense will rise. Okay, that's a clue for you. This is your clue. Cold water is more dense than warm water. Cold water, higher density, sinks, and lower rises. So explain convection with that information. Okay? Compare what happens with the red dye in the water bin with what happens in the hot air balloon here. How is the same principles responsible for the balloon rising? Number 4, recall that matter cannot move without energy. What is the source of energy that moves the red dye? Where does that energy come from? What is the source of energy that moves the blue dye? Number 5, why is the motion of the water in the bin considered a cycle? What can stop the cycle? What can speed it up? Describe the forces that move the floating pieces of wax or chocolate. How did the force relate to the direction of water flow in the bin? Okay. Why is it that those pieces of chocolate or wax were moving? And where was the force on it? And how did that, how does that correlate with which direction those pieces were moving? And then water has a low viscosity. It's not very thick, right? Things like honey, syrup, those have high viscosities. How might the movement of the dyes change if you had a higher viscosity liquid? What if we used a thicker liquid like honey? How would that change it? Would you think it would move faster or slower? Why do you think that? And finally, evaluate the food coloring in the water bin model. What are the strengths and limitations? Like, how is it a good model of thermal convection? And how is it I wouldn't say a poor model, but like in what ways is it not really doing a perfect job of modeling thermal convection? For each one of these, look at the point value. Those points should indicate to you approximately how many sentences it should be. Okay? Number 5, there's 3 questions being asked. Obviously 3 points, a sentence per question. So use that as kind of your guideline to know what to do. Okay, so I just want to say, let's see here. All right, hopefully you guys, that was a helpful video tutorial for you. If you have any questions beyond this, whether it be on some of the questions in the follow-up for the convection portfolio or anything else, give me a call at extension 2204, or you can send me a webmail message. Hope you have a great day.